Alright, you guys, today we are starting section 9.2, which covers solving quadratics with graphing. So just to review, a quadratic equation is when we have some number x squared plus bx plus c is equal to 0. So that's what we've been spending a lot of time working with over the past few weeks. In example 1, we're going to be looking at quadratics that we can solve and that are going to have two solutions. So we have an example here. We want to solve x squared plus 2x equals 3 by graphing. Now, I'm going to show you how to solve it the easier way without using graphing, but then we will also make that connection with the graphing just so you can see how they're related. But I do think it's a little bit easier to just solve it by factoring instead of making a graph every single time because that can get time consuming. So your first step is always going to be the same. Look at how in blue I have rewritten the quadratic equation in standard form so that it's some number x squared plus some x term plus a constant. So the way that I did that was by subtracting 3 from both sides. And now I have the quadratic written in standard form. Your next step then is going to be to factor that equation. So I'm thinking what two numbers multiply to equal -3 but add to equal +2. So I've factored it by writing x plus 3 multiplied by the quantity of x minus 1 equals 0. So then once I have it factored, I can go ahead and find the solution so that I know that either my first set of parentheses or my second set of parentheses must be equal to 0, which means that my solution is going to be either x equals -3 or x equals 1. And that is your final answer there. So I didn't use a graph. I think it's easier to just kind of factor and then solve that way. But I will go ahead and show you the graph as well so that you can see how to find the solution while graphing. So if I were going to make a graph, I would start by showing where both of the zeros are on the x-axis, the x-intercepts, and those are going to be -3 and +1. And then I also drew in the axis of symmetry as the undefined line x equals -1, and that's going to be my line of symmetry for the parabola that I'm about to draw. So this is a review of chapter 8, but I know that the vertex of my parabola is going to fall somewhere on the axis of symmetry. So the way that I figure out the vertex is I'm going to plug in -1 as the x value to solve for the y value, which will tell me what the vertex is going to be, where that's going to fall on the axis of symmetry. So when I solve that math, I see that -4 is equal to y. And that means that my vertex is going to be at -1, -4. So I'll go ahead and draw in that vertex and then create the parabola shape. And again, I'm seeing that there are two solutions. There's two spots where it crosses the x-axis. I just personally think the added step of graphing it is a little bit extra, so I just prefer to stick with the easier route. So here are your 3 monitoring progress problems. If you want to create a graph, you may, but if you prefer to just factor and find the solutions that way, that is also okay, and that is how I'm going to model the answers after you guys give it a try. So in number 1, I will start by factoring that quadratic equation. I know that -2 times 1 is equal to -2, and -2 plus 1 is equal to -1. So there you have it factored. And then from there, I can easily tell that the solutions are going to be 2 and -1 because either of those, the expressions within the parentheses has to equal 0. So those are the solutions to that quadratic equation. No graph, just kind of took the easier way there. So our second problem here requires an extra step. Notice that it is not in standard form. So I'm going to add 10 to both sides so that I can get it in standard form and get the quadratic equation equal to 0. From there, I went ahead and factored the expression so that it is the quantity of x plus 5 multiplied by the quantity of x plus 2 is equal to 0. So the solutions are going to be x is equal to -5 and x is equal to -2. Again, I have two solutions here. If I were to graph it, it would cross the x-axis. There would be x-intercepts at -5 and -2. But really that added step of graphing is not necessary. I've already found the solutions. For problem number 3, again, my first step, I do need to rewrite the equation in standard form. So I do that by subtracting 12 from both sides, and I'm left with x squared plus x minus 12 is equal to 0. From there, I will go ahead and factor the expression, or factor the equation. So I have the quantity of x plus 4 multiplied by the quantity of x minus 3 is equal to 0. And once it's factored, I can very clearly see that the solution to this equation will be x is equal to negative 4 and x is equal to positive 3. So again, we have two solutions. If I were to graph it, those would be the x-intercepts.